Alrighty. Acceleration is found by doing the change in velocity or change in speed over time, over change in time. And deceleration is exactly the same, but it accounts for the fact that we are slowing down. So actually, if we are slowing down, this thing will be positive. It's just a slight little a change to deceleration. So we can see the change in time is it travels from the library to the town hall. We're going up and then we're going down. So we can see it's talking about this bit here, 20 seconds, and we're going down by 6. So the deceleration is going to be 6 divided by 20. Okay, the acceleration would be minus 6 divided by 20. That's the difference. So we get 3 over 10. I mean, you can use a calculator for this, but I've done it without 0.3 meters per second squared. Calculate the distance travelled by the tram between the library and the town hall. Right, for that we need to remember that the distance is the area under the graph. I'm not going to go into why that is here, but it is sort of related to the speed equals distance over time formula. But that's only true for average speed or a constant speed. Do you know what? I said I wasn't going to go into it, and I just realised I'm really totally going into it. But hey, so if distance is speed times time, if you were going constant speed, then and you did speed times time, you would get the area under the graph. And although this is only true for constant speed or average speed, it does actually, you can use it in general that it's the area under the graph. It's a bit more technical why it's the area under the graph, which I'm not going to go into. I'm just going to say, except it's the area under the graph, but here's a bit of reasoning why. All right, so to do that, it's just half base times height. It's going to be a half times 85 times 6, which is going to be, I just feel like doing this without a calculator. Half of 6 is 3, so it's going to be 3 lots of 85. 3 lots of 80 are 240. 3 lots of 5 are 15. It's going to be 255 meters. What's the maximum speed of the tram? Well, it's 6 meters per second, but now we have to change this to kilometers per hour. So let's take our time. First thing I'm going to do is I'm going to change it to kilometers per second. So for that, I would divide by 1,000, because that's how you go from meters to kilometers. So that's kilometers per second. How do I then change it to per hour? Well, I'm going to change it to per minute. And what do I do for that? Well, to go from seconds to minutes, you divide by 60, and to go from minutes to hours, you divide by 60. But this is per second, so actually you do the opposite, you times by 60. Another way to think about it is I'm going to go more distance in a minute than I am in a second, so it doesn't make sense to be dividing by 60. So it's going to be 6 times 60 times 60, and I still need to divide by this 1,000. But this is great. You could chuck this into a calculator, but I can cancel one of those zeros off with that, cancel a 0 off with that, and then 6 times 6 times 6 is actually 216, so it's going to be 216 divided by 10, which is 21.6 kilometers per hour.